T-Series Telco accelerator cards are Xilinx's 5G Open vRAN solution targeting the virtual baseband market. They have been developed for offloading and accelerating the compute-intensive functions of L1 Hi-Fi. When the T-Series solution is used in their distributed units, operators can target any radio vendor irrespective of the baseband vendor, thus increasing flexibility, scalability, and interoperability of the RAN. The ability to plug in T-Series cards into a commercial off-the-shelf server rather than using proprietary custom solutions from a limited set of hardware vendors reduces vendor lock-in and total deployment costs. It also increases the agility of the vRAN as operators can quickly adapt to changing vRAN requirements and diverse workloads. We have developed two cards, T1 and T2, for two different target markets. T1 is covered in another video on Xilinx website and can be used for offloading both LDPC and front-haul termination functions. T2 is focused on offloading the compute-intensive LDPC FEC functions with higher throughput, lower latency, and smaller footprints. T2 cards feature RFSOC ZU48DR devices which support PCIe Gen 4. T2 is intended for very high throughput DU deployments. T2 is a half-height, half-length PCIe Gen 4 card which can support both 5G LDPC FEC offload and 4G turbo code processing in look-aside mode, all within a 50-watt power envelope. As T2 is a pure look-aside L1 accelerator, it can be paired with a standard NIC card. The entire PCIe bus is dedicated to the Xilinx RFSOC ZU48, whether that is 1 Gen 3 x 16 or 2 Gen 4 x 8s. The ZU48 has 8 SD-FEC blocks, which can be configured as standard cell ASICs supporting LDPC Encode and Decode or 4G turbo coding. T2 is compatible with industry standard BBDev API for baseband LDPC offload. Here's the setup for our T2 virtualization demo. We have a T2 card plugged into a server with an AMD Milan CPU and Ubuntu OS. It is supporting dual PCIe Gen 4 x 8. In this demo, we will show you two configurations. One uses two VMs which represent two virtual DUs sharing the LDPC resources on the card. The second uses four VMs sharing the same LDPC resources on the card. What you will see in this demo is that all VMs have access to all LDPC acceleration resources, and that we do not see any degradation in performance based on the VM architecture you choose. Here we see the BBDev application that is running on each VM. When the T2 card is in the system, the LDPC HARC and code block CRC and the rate matching functions are offloaded to the T2 card. This greatly increases performance of each VDU by alleviating the loading on the CPU. In case number 1, we have two VMs sharing the resources on a single T2 card. As we turn on the traffic, both VMs run at their maximum rate at the same time. The card is achieving 12 plus gigabit per second decode in this configuration. Similarly, the card achieves 35 gigabit per second of encode in this configuration. In case number 2, we have four VMs sharing the resources on a single T2 card. As we turn on the traffic, all four VMs run at their maximum rate at the same time and lets us see how the card performs. The card is achieving 12 plus gigabit per second decode with four VMs. The card achieves 35 gigabit per second of encode with four VMs. This demo shows T2's potential as a virtualized DU accelerator, acting as a pooled resource that can maintain its maximum throughput regardless of the number of VMs running. DU pooling is a key value proposition of virtual BBU. This video demonstrates the T2 card's capabilities running in multiple VM environments with no degradation in performance. T2 is a pure L1 accelerator targeted for dense urban deployments, including both 32 TRX and 64 TRX massive MIMO radios. Since the entire 200 gigabit per second of PCIe Gen 4 bandwidth is dedicated to the L1 Hi-Fi offload in ZU48, T2 provides a significant improvement in L1 look-aside performance compared to other products out there. Thank you for joining us in this quick overview of the performance that can be accomplished with the Xilinx T2 accelerator card. For more information on T2 or the applications it helps to enable, please visit Xilinx.com.